In this video, we'll be turning language into math magic. Hello, math learners. Hassan here. Today, we are diving into the exciting world of algebra with a topic that acts as a magical bridge between words and numbers. That is, verbal expression to algebraic expression. Okay, so let's start this topic. First, we'll explain what is meant by an expression. An expression is a number, a variable, or a combination of numbers and variables using operation symbols. Earlier, we have seen the examples with Greg's age and Alex's age. We have x and x plus 3. Both of these are expressions. Over here, we can see that x is just a variable and x plus 3 is a combination of numbers and variables using operation symbols. Another way to remember the expression is that an expression is like an English phrase. So in math, if we have 3 plus 5, we can explain this in English phrase as the sum of 3 and 5. This is what we call the verbal expression. Similarly, if we have n minus 1, in English phrase, we have the difference of n and 1. 6 times 7 can be read as the product of 6 and 7. X divided by y can be read as the quotient of x and y. Up next, we have an equation. Now, an equation is when two expressions are connected by an equal sign. In English, if you analyze the difference between a phrase and a sentence, we can clearly see that a phrase expresses a single thought that is incomplete by itself, but a sentence makes a complete statement. Here we can see that 3 plus 5 equals 8. The English sentence is the sum of 3 and 5 is equal to 8. This is expressing a complete statement. N minus 1 equals 14. The product of 6 and 7 is equal to 42. X is equal to 53. Y plus 9 is equal to 2y minus 3. So here is a quick trick. When you solve any word problems or come across any verbal expression, the action verb will give us an indication of the equal sign. So keep that in mind going forward. Now, when it comes to English phrases, there are many synonymous terms that will be often used to exchange between words and phrases. Similar analogy can be applied over here. We have many different ways to express addition, subtraction, multiplication, and division. Here are a couple of examples for each one of them. For addition, we have a plus b, the sum of a and b, a increased by b, b more than a, the total of a and b, and b added to a. All these represent the meaning as a plus b in the math expression. Similarly, if you have a minus b, this can be translated as a minus b, the difference of a and b, a decreased by b, b less than a, and b subtracted from a. Here is a quick note that for these last two phrases, we don't write these as b minus a. That is incorrect. So b less than a or b subtracted from a is written as a minus b, not b minus a. Now for multiplication, we have a times b, the product of a and b. This represents as a dot b or ab or a parenthesis b, or within parenthesis a times within parenthesis b. All these are representing same as a times b or the product of a and b. Now the next multiplication we have is twice a. We can write this as 2a. Now you can see that multiplication is the only operation which is not shown in the algebraic expression or equation. So instead we just keep it invisible, or we can also use dot to represent this multiplication or this parenthesis, but we don't write this as a times b, because this multiplication operation can get confused with the variable x. So that's why we just keep this operation invisible. The last one we have is division. So a divided by b, the quotient of a and b, the ratio of a and b, b divided into a, all these are carrying the same meaning as a division operation b, or a over b. So keep that in mind going forward. Now, we also talked about exponents earlier. We have mentioned how exponential notation is written. Now we'll see how this can come in the word form. Again, a quick note is a to the power of n means we multiply a by itself n number of times. Here a is called the base and n is called the exponent. And this is read as a to the nth power in the verbal expression. So 7 square, we can write this as 7 to the second power. 5 cubed, we can write this as 5 to the third power or 5 cubed. 9 exponent 4, we can read this as 9 to the fourth power. 12 exponent 5, we can write this as 12 to the fifth power. So these are the verbal expressions that we can use for the exponents. Okay, so the problem statement says write each as an algebraic expression. So the first one is the second power of 6. So we have this 6, and now we take the second power on top of this 6. So we have these 2 coming as an exponent. So we have 6 to the power of 2. So we can also say this as 6 to the power of 2. So this is how we write this algebraic expression. Now the second problem is n increased by 11 is 39. So n increased by 11 is, we have this n, increased by translates into plus sign. So n plus 11. The word is referring to equal sign, 39. This is how we convert the verbal expression into algebraic expression step by step. The next one, a number minus 18. So you can take any number here. Let's take this number as x minus 18. So the variable x is representing any number. Since it does not specify the variable, we can take any letter over here. Number 4, it says x increased by 12 is equal to 39. So again, we have this x. The phrase increased by refers to the plus sign. We have 12. So x plus 12 is equal to refers to the equal sign, 39. Okay, number 5, we have x squared is equal to 12. So we have x, and then we take square. Is equal to means equal sign. Then we have 12. So you can see that how we are breaking down these verbal expression into algebraic expression. Number 6, we have the second power of 10. So we have this 10 as the base, and we take the second power, which can also be read as 10 to the power of 2. Number 7, we have 12 more than t. The phrase more than refers to the addition. So we have 12 plus t. Number 8, the quotient of k and 6. The phrase the quotient of refers to the division sign. So you can write this using fraction bar. So the quotient of k and 6 is k over 6 is equal to translates into the equal sign, 27. Number 9, we have n more than 11. So you have n plus 11. Number 10, we have n divided by 8. Again, this divided by phrase refers to the division. So we have n over 8. So for division, we can always use the fraction bar. Is referring to the equal sign, 40. Number 11, we have k less than 23. Now here is the trick. The phrase less than refers to subtracted from. So don't get confused with this. Oftentimes students write this as k minus 23. So this is incorrect. We have to write 23 minus k. Remember, less than means subtracted from. So we can write this as k subtracted from 23. So we write 23 first and then subtract k. So this is how we translate this expression. Number 12, we have x divided by 5. So that's pretty easy, x over 5. This is how we convert this verbal expression into algebraic expression. Number 13, we have half of x is 19. So half of x, we just take 1/2. The word of refers to the multiplication. So this is very important. Anytime if you have the word of, this refers to the multiplication. So half of x means 1/2 times x. So I'm using a dot over here. Is referring to the equal sign is 19. So we can also write this as 1/2 x equals 19. So we can just skip the dot. Number 14, we have the difference of z and 9. So the difference referring to the subtraction. So we have z minus 9 is referring to the equal sign 30. And the last one that we have is n cubed is equal to 47. So n cubed referring to the n. Then we have an exponent of 3 is equal to referring to the equal sign 47. Awesome. Okay, now we'll see how to convert the algebraic expression into verbal expression. So this is the opposite of what we just did a while ago. Number 1, we have 54 over w. So we can write this as the quotient of 54 and w. Number 2, we have n times 10 equals 34. So you can write this as the product of n and 10 is equal to 34. Again, we can write this in different ways as well. N times 10 is equal to 34. We can write it that way. So just know that you can write it in any ways you can think of. Just this is a quick practice just to make sure that you can understand the reverse process as well. So this would help in solving the word problems. 10 minus 8, we can write this as the difference of 10 and 8. Number 4, we can write this the 7th power of x is 8. Number 5, we can write n increased by 8 is 24. Number 6, let's write it in different ways because both 5 and 6 are same. So we can write this as v more than 11 is equal to 6. Number 7, we have the 2nd power of x. Number 8, we can write this as n times 11 is 37. You can see the variations that we are bringing in. So all these different verbal expressions can help you to know the process of this conversion. Number 9, we have n. Let's write it. The product of n and 12 is equal to 28. And the last one, we can write it as 2 cubed, or we can write the 3rd power of 2. Awesome. And there you have it. Remember, mastering this skill is your key to translating everyday language into the language of algebra. That's it for this video, and I'll see you in the next one. Now, let's get me studying.